Hey, Sean's here. This will be a little bit of a break from the solutions, just doing what I think is necessary before we go a little bit further, going into the shell scripting, because the shell scripting doesn't necessarily have anything to do with the entire process of, if you notice, that this task 11, is to write shell scripts on server 1 that create users and groups according to the following parameters. And then ensure, of course, that all users except Cindy use AutoFS for their profiles. So you would see these parameters here, but we haven't really touched on really manipulating user profiles and authentication in groups and all that. So I figured it would probably be best to do a little kind of quick little cram on all the different things you can do to manipulate groups and users before we actually went ahead and read the shell script. That way it's a bit more focused as far as the task solution goes. It's a bit more focused on actually solving that task instead of teaching you both about manipulating users into groups while also doing shell scripting, because shell scripting itself is enough of a Herculean task that we don't really need to add in explaining an entire ecosystem of granular control, right? So I figured I would touch on this first, so that's what we're going to do in this video. So before we go into actually manipulating users and groups, let's talk a little bit about files, directories, and the permissions that are attached to them, because I think this is kind of important to understand before we actually talk about manipulating users and groups. So at a base level, whenever a file is created, the creator of that file is the owner and is also simultaneously the group owner. So I'll go ahead and kind of demonstrate this. If we do user add SeanZX, for example, then right now we're in the home directory. So we're going to go into the newly created SeanZX directory that was just made. You can take a look around here, nothing in here. So let's go ahead and just make a test file. This file.txt. There's nothing in it, you can see, because it's empty. So let's go ahead and also list the kind of information about it. So you can see here it is a normal file because the first bit is just a dash, indicating that it's not like a directory or anything. That's the special bit of a file permission. Then we have the user group here, or rather the user triplet. So this indicates that the file owner has read and write permissions, doesn't have execute permissions. The group owners have read and write permissions, no execute, and then the other group, which is everyone else on the system, they don't have any permissions whatsoever to this file, so they can't touch this file at all. It's completely separate for them. And then we have the user ID, or rather the username, and then the group name, and then some other extraneous information like the date of creation. So what exactly does all this mean? Now, obviously, I think the file permission bit is a bit self-explanatory. If you've had, experience with Linux at all, then you know at kind of base level, these bits right here, these security bits or permission bits, as they're officially called for the total file mode. These are, of course, referencing the actions that a user can take upon this file. So, of course, the SeanZX owner, they could read and write this file. And also their group, the group SeanZX, any users in the SeanZX group can also read and write the file, but nobody else can. So it's also important to note that in Unix and Unix-like operating systems, whenever by default, in most cases, you'd have to turn it off or edit some configuration in order to disable this, but there's something called a user private group, otherwise referred to as a UPG. And so with this UPG, as I said, when a user is created, they all have an attached UPG as well, and that will typically be of the same exact name as their username. So, for example, this SeanZX user will have a UPG of SeanZX as well. And what this does is allow for an added layer of security and granular control through this addition of this private group, right? Because we can do some things specifically to that aren't necessarily directed at the user itself, and it allows us, like I said, an extra layer of granular control. Now, you can not typically see exactly, there's no way to like list out all the user private groups on a server unless you're using something like IDM, which is like the Linux equivalent of Active Directory. There are some commands you can do that, but that's outside the scope of this. For our purposes, however, there are a few different ways you can kind of poke around and see if a user has a user private group. It's notable to keep in mind that most service and system accounts won't have a UPG attached to them. It's just not necessary for them, and it would probably do more harm than good, so they don't typically have them attached. Now, we can do something like ID and the username, and this will show you kind of the user ID and group ID information about a user. So you'll see right off the bat, we have the user ID of 1000 for SeanZX, then the group ID of 1000 for SeanZX as well. That's also showing the primary group name of SeanZX. So important to note between the GID and the groups field there, the GID shows, again, the primary group, and it's like 99% likely if the group ID group name is the same as the user ID username, then it's probably likely that that's a UPG or a user private group. Now, the final thing, the groups, now you may be wondering, well, all I see is SeanZX as well, so how am I supposed to know the difference there? There's the same exact information, it just says groups instead of GID. Well, you may notice that it's groups, plural. So if we do something like this, so we'll go ahead and use the group add command, and you can only add one group at a time, unfortunately, with this command. So we'll go ahead and add test group 1, then use the history to add a second one. And you can see those are added by doing the, sorry, wrong one here, add group. This is basically the equivalent of adding the etc group file, where this is basically where it pulls it from. You can see it does the exact same output. You can also note that we have the SeanZX group in the etc group file. So that's also further proof that we have a UPG of SeanZX created with that SeanZX user. So now that we have done that, we just need to actually add SeanZX to those groups. So we'll use the -A for append and the uppercase G for the supplementary groups, which allows us to list a number of groups to perform an action to, separated by a comma. And then finally, the last parameter will be the username that we wish to add, or rather the user that we wish to add into those groups. So the command concluded successfully. So now if we do ID SeanZX, you'll note that the final field there, the groups field, now has multiple groups listed in it, while the GID field still remains SeanZX, indicating that the user's primary group is SeanZX. And again, while that's not fully confirmation that this is a user private group, in 99% of cases that means that the user's private group is SeanZX and that it actually has a user private group, because the user primary group is SeanZX, and that would be very strange for that to be the case without, of course, being UPG. So a little bit kind of weird, a lot to take in, I know there, but that's essentially how you can kind of prove that. And also at the same time, this is a better way to kind of get an idea of what exactly the ID command is showing you here. And while we're kind of here talking about the output of the ID command, let's talk a little bit more about the UID and the GID, right? So that kind of funnels back into the security bits or the permission bits. The UID is, of course, the user's ID, and the GID is the group ID. And what these do is attach, of course, a decimal value to the user and allow for some deeper modification at a lower level. Now, it's important to note that RHEL reserves UIDs and GIDs below 1000 for system users and groups, and they recommend that you do not use any UIDs or GIDs below 5000, just to allow for future updates to make use of that addressable space. Now, of course, you are free to go ahead and use that, and in this lab we are using some user ID and group IDs below 5000, but it's just generally, again, recommended by them to not do this in an enterprise environment. Now, of course, the RCSA lab exam doesn't exactly require you to do this, so it's not something I'd assume that you'd be penalized for come exam day. But again, just something to keep in mind for the future, just to save yourself some headache in an enterprise environment again when some update comes in and kind of messes up a bunch of your user profiles and settings that you have set up because they created some system account that tried to conflict with an already existing UID or GID. And so speaking a little bit further, of course, again, on permission bits and the whole concept of a file node. So it's important to note that only root can change who owns a file, not even the file owner themselves can change who owns the file. Again, only root can do so. Now, the file owner can change the group owner. So the second triplet of permission bits, they can modify that. And if you're wondering why I call it a triplet, it's not the official terminology for it, but that's just to refer to the fact that it does contain, so each set of permission bits is essentially a triplet as far as the binary to decimal conversion goes, because it's 0 to 7, which is 8 digits, and of course that is in binary a triplet addressable space, kind of similar to with IPv4. We have octets for the addressable digits in between from the binary to decimal kind of conversion there. So that's why I'm calling it that. So that's how you can kind of envision it. Each triplet is what I'm essentially calling each set of permission bits, like the user owner, the group owner, and the other owner group. Now, of course, the file owner can also still, of course, change the permissions on the file itself, the permission bits. Again, they just can't change who actually owns the file. So they can say, hey, this file, testfile.txt, yeah, I want this to now be executable. Like, they can go ahead and do that. And then we list it again. And we see that this is now executable. Obviously, I'm root, so that's, you know, that's why I'm able to do it too. But if I was on the ShawnZX user, I could set this to be executable by, of course, everyone there. So that's just, of course, an example in kind of differentiation between what they can do. Again, the file owner cannot change who owns it, but they can change the permission bits, as I just showed there. You can basically, if I was the ShawnZX user, I could have done the exact same thing. Now, speaking further on this, again, like I said, the file owner can also change the group owner. And so when it comes to the permission bits and how they are applied in terms of a user accessing a file, you need to think of this as like a first come, first serve kind of matching process, right? When the operating system is looking at, or rather trying to determine what a user can do in regards to its relationship with the file, it'll first look at, it'll kind of go down from the top to the bottom, checking each one, and then the first one that it checks against, those are the permissions that the user accessing it will be assigned. So let's say, for example, I'm on the user, I don't know, Tom, and I'm trying to access a file that ShawnZX owns, right? So Tom is obviously not the file owner in this case, ShawnZX is. So when it goes, when the system goes and compares the permission bits there, it'll say, hey, this is owned by ShawnZX. Tom doesn't own this file, so no, we're not going to give him the permissions in the user group. We're going to go down to the second triplet. We're going to check those permissions. We're going to see, hey, is Tom in the group that owns this file? Well, the user primary group for this file currently is ShawnZX's group, so we're going to see, is Tom in ShawnZX's group? Nope, he's not, so we're going to go down. Now we're in the other group. This is pretty much the default for everyone else on the system. We're going to go ahead and see, is Tom in this other group? Yeah, what can the other group do? Well, it looks like they just have read permission. So it'll say, okay, Tom, the user Tom can read this file. That's all they can do, and that's all they'll be able to do until that is changed or configured by either ShawnZX or root, or whatever system administrator account might be on the system. Now, the question comes to mind, or at least for me, one of the first questions I had was, well, what if we have an other group where everyone in the other group can read, but the user accessing the file is in a group that only has write permissions, right? What happens then? Does the system add them together somehow? And the answer to that question is no, because again, the system is just automatically basically matching you into the first matched group again. So it's whatever you match first, it from that top to bottom structure is what you get put into. So say again, we have the same file, except now Tom is in the ShawnZX group, for example, just to make things simple. So again, we're going to go from the top to the bottom, start at the ShawnZX user group. Is Tom in that is Tom ShawnZX the user? No, so he's not the file owner, so we go down from that. Then we go to the second one, which is the group owners. Is Tom in the ShawnZX group? Well, he actually is. And this group has only write permissions. So even though the other group has the read permissions, And ordinarily, Tom would have fallen into that group and been able to read that file because he matched that group, that group ownership bit. He's only going to be able to write. He cannot read and write. It does not add the permissions from any other successive layer that the user might fit into. It's just going to give you the ones from that first available match. So this, you may be wondering, why is the point? What is the point of that? That's just to, again, allow for more granular security control. Because let's say you have a user account, or a user account for a service or system program. Let's say that this service doesn't necessarily need to read anything. It's just going to output some text to a file. So it's basically like any typical logging file, maybe, or program. Maybe all it does is just write some data from an output stream into a file. That's all it does. Now, does it need to read anything? Well, in the scope of what we know it can do right now, no, it doesn't need to read anything, because again, all it's doing is redirecting an output stream into a file. So why would we need to allow it to read, right? We can just set it into that group of, let's say when we have like a logging group, and we set that program into that logging group. So again, it's not going to get the permissions from the user owner group. It's just going to go straight down to the group ownership bit, and it's going to get those write permissions, and that's it. That's all it's going to get. And that kind of adds an additional layer of security again, because let's say we have some attacker, bad actor, black hat actor bars that is trying to access that logging group as an attack vector, right? Let's say he actually manages to add his terminal session into that group, that logging group, through some vulnerability or flaw. Well, even though he's in that and he can write to, any files that this service might have access to, he can't actually read them. He can only write to them. And while he might be able to do some damage writing to it, because he doesn't necessarily know what's in it, then it kind of prevents him from knowing the structure of everything and kind of knowing where that flow might go to, right? He might try, of course, being able to write. He might be able to replace the entire contents of a file and break something, but he's not really going to have an idea about the environment around him, right? He's only going to be able to maybe disrupt the contents of a log. Maybe he writes into that log, haha, losers, you can't get me. But that's really all he can do. Maybe he tries to inject some script or some logic into a text file, but if we also have some additional security controls in place, then the output of that log file isn't going to really be able to realistically perform any attack that would be able to disrupt our activities, right? It'll just be kind of an annoyance, and then when we see that there's some suspicious activity coming from that logging group, we can further contain it, quarantine it, and perhaps scrub the attacker out of our system. And very quickly, I just wanted to let you know that the official terminology for that is called discretionary access control. That's RHEL's official terminology for it as well, but it's kind of a standard practice throughout IT and cybersecurity and our industry at large. So just wanted to put that out there. Not, again, since the RHCSA is a practical exam, not really something you'll ever be tested on, but it's a pretty good buzzword, honestly, to know, good jargon to know, and you'll probably hear it every now and then. Now, you may be wondering, where can I find the UIDs and GIDs that might be reserved? As I mentioned earlier, anything under 1000 currently is reserved for system users and groups. So you can quickly see that by just catting this file right here. And this will be in, actually, this is the wrong, it's not in Etsy, it's in shared doc setup. And you'll kind of be able to see, it'll list a bunch of files here. So you won't necessarily be able, like if you have a bunch of users on the system, you need to actually do this, my bad. You want to see this and then use UID GID. That way it shows you all of them at once, because some of those might be hidden, of course. And of course, if you need to pipe this to more to kind of scroll through it a little bit easier, you can go ahead and do so. Take a look at all of them. And these are pretty much all of the system files that you would have available here. Actually, can we type this to less? Yeah, less is a little bit better here. But we can scroll through it with E and stuff. And this gives you, again, an overview of all the UIDs and GIDs that you might have on your system, what they might be used for, the file locations, and everything. So pretty nice breakdown. And you know, if you needed to perhaps do something with this data, then of course you could like redirect it to maybe a file, do like cat this, and then redirect that to, I don't know, setup.txt, and then we can just cat setup.txt example whenever we want to, or maybe do some changes to this right here and then copy that over and then back that up and everything. So that's just something you can do, of course, with that. And we will go ahead and remove this. Yes. And we just have that. Now, again, RHEL officially recommends that you start any new UIDs and GIDs at 5,000 just to kind of future-proof your system. But again, not a hard rule. And if you wanted to set a lower bound for new users to start at by default, just to kind of save you some time and, you know, heat presses, then you can go to the, I believe it's the login.defs file. So you can go to, let's see, login.defs. And then just search for, I believe the value is, just search for UID. I probably should have just done UID underscore min. But yeah, you can go to this value and you see how it's set to UID min and UID max. You can just go here, just go up, or whoops, yeah, let me go KKK. Go to the end of this, and you can just change this to like 5,000, for example, at a baseline. And there, that way that it just starts from 5,000. So anytime you create a new user, for example, we right click that, and then let's just exit out, log back into root, do user add test user. We ID the test user. You'll see that they started at 5,000 instead of the previous one. So go ahead and into this, UID min, go back up. I blind. There we go. And set that back to 1,000. So now that we understand kind of a little bit more about the low level workings of groups and users IDs, I'll touch on some commands that you can use for group manipulation and some useful options for them. So first, we've already used most of the ones that I'm going to show you, but just to kind of give you a refresher, there is the ID command, and you can also just set it to ID just to show kind of the base accounts. But generally, the syntax is just you use ID, then the name of the user that you would like to show, and it'll go ahead and give you some information, like of course the UID, the GID, and the groups that they are a part of. Then we have the user add command, which does very well what you might believe it to. It allows you to create a user account. Now, there are options that you can use for greater specificity, and the syntax is usually just user add, then the option, and then the username. Now, some useful options are the -G, and that's an uppercase G, and that's to add a user to a specific group at its inception. So we can do like this user add -G test group 1, and we'll name this test user 2. And then we can see that this test user 2 has also been added to the test user 2 group. Well, that's of course its user parameter group, the UPG, and it also has been added to test group 1 at its inception. Now we also have another option. We have the -N command. And this command is useful as this is pretty much the -N or the -no user group command. This is really the only way to prevent the automatic appending of a user to a user primary group, or rather user private group, the UPG. So if we do like user add -N, but we'll add it to, actually let's do, what can we do? We can do -N G, and then we can say we're gonna add it to test group 1 and no group user. Let's do no UPG user will be the name, and then we'll do ID no UPG user, and you'll see that the primary group is actually not the GID 100, it was put to the default of 100, which is the users group. And that is actually intended behavior. If you don't have if you use the -n flag, it will look in the, I believe, the etc default user add file, and it's dependent upon a variable in there called the group variable, rather, in the etc default user add file, which is at 100 by default, which obviously you can see there is the users group. So that'll kind of prevent you from using the UPG. And then of course you see that it was also successfully added to test group 1 as well. Now we'll take a look at the -c or the -- comment command. So we can do user add -c, and then what this does is, again, it's a comment, so we can use it to add some additional descriptional information. And this is useful for doing things like the user's full name or other relevant information that we might need to put, like their title, job title, or whatnot. So we'll do, like, say, Paul McGee, and you put obviously I just put the description first, or the comment first, and then I'm putting their actual username. So you can see that completed successfully. So now we'll use getEnt password to specify the database of the password file. And then we're going to use a key value, which is going to be the user, Paul McGee. And you'll see that right here. This is the comment that we just added, Paul McGee, right there in the 1, 2, 3, 4, 5th field, right there before we specified their home directory and the interactive shell that they are assigned to be able to use. So the last few flags, I'll just kind of run through them without actually using them, just because it's a bit of a pain to like use them for these accounts and kind of show it off. So we have the -e or the expire date option, and that's just to set a date at which the user account will expire. Kind of self-explanatory. We have the -f or the -- inactive command, and that's, again, a lowercase f. That's to set a date at which the user's account will become permanently disabled after their password expires. So let's say that their password is set to expire in 5 days. After that 5 days is up, their password will expire, and they'll need to, create a new strong password. If they, of course, don't set it within, say you set the value to 5 days afterwards, then their account is going to be permanently disabled, and, they'll need to reach out to the system administrator to have their password enabled again. And this is dependent upon an inactive variable within that etc default user add variable, same place or file, and that's kind of the same place that the primary group, rather, the UPG, can kind of be edited, in case you didn't want, of course, to have a user private group created on every account's inception. Then we have the -u flag or the --uid flag, and this is, of course, to set an initial UID upon creation. Kind of self-explanatory. If you don't want it to be, of course, say you start at 1,000 and you don't want it to be 1,000, you want it to be some other value, you can use this to set it to that other value. Then we have and just to also mention, this must be unique unless you add the -o option. The -o option just stands for unique, just to let you know, and that's a lowercase o. And then we have the -uppercase-U or the --user group option. And, if you have user private groups disabled, this is basically a way to kind of override that if you want specifically for this one, for example, to do this. And this will create a user private group on creation. Basically, it'll just replicate the username for that user to be the name of the user's primary group. Again, that's basically what a UPG is, or a user private group is, essentially. Then we have the -c command, and this is an uppercase C, and this is also known as the --se Linux user command. That's kind of going to be its own separate video, and that's going to be a long one because SE Linux is very complicated, difficult to use, has a reputation for being difficult to use. So I'm not going to explain it really much further than that, honestly, but I just want you to be aware of that option as something you can do, and I'm sure we will discuss that in detail once we get to SE Linux. And that's it for the user add command, so we'll be moving on to the next one. So the next command is the user mod command, and we've already, of course, seen this so far when I did the user mod -and supplementary groups command. And this can be used, of course, if you can figure out from the name, to modify a specified user account. Now, the syntax, of course, is, as I just showed, user mod, the option, and then the username that you wish to apply that modification to. Now, some useful options are, first, of course, the -a, which is one that we used before, or the --append command, and that, of course, is a lowercase a, and that is pretty much only going to be used with the uppercase G command. In fact, it's recommended in the official documentation to only use it with the uppercase G command as you need to. to append the user to. And this of course is followed by the next option, which is the -G or the -- groups command. And this is essentially a way to specify a list of groups as parameters to which you wish to perform an action against with the user's account. And many of the same options, honestly, as the user add will be available. The user add command will be available with the user mod command. So I'm not going to list as many because they kind of overlap. So many of the ones that I just listed, you can kind of go back and look at, but some significant different options that they have with user mod is the -L command or the -- lock command, which locks a user's password for their account. It does this by just prefixing a exclamation point to the hash of their, or rather the encrypted, well, same thing, the encrypted value of their password. And you may be wondering, well, why do you say lock the password? Why not? Why wouldn't you not just say lock the account? Well, that's actually kind of different things because, again, there are more than one ways to access and log into an account besides just the password. In Linux and honestly in most systems, you can log in with other ways as well. So this will again just lock the use of the password as the main authentication method to log into the account. So you would still be able to SSH in and use that fingerprint and asymmetric key encryption method to log in, but you wouldn't be able to use the password. So that's just kind of what you can use that for. And you can also unlock it with the --u command or the -- unlock, but you can only do this as root, just to give you a heads up. So just be aware of that. Also be aware that when you lock a user's account, you also need to specify an expiration date, and you would need to typically set that value for the expiration date to 1. And you can do this by using this in tandem with the -e or expire date, -- expire date flag. And the format is specified in the typical like YYY and MDD style. So this is the format in which you would specify the expiration date. An empty value here just disables expiration. And it's also important to note that, of course, for a password expiration, you need an etc shadow file, and the command will essentially create one when you use like the expire date or the. Next we have the password command, and pretty simple command. Just updates the user's authentication tokens using Linux PAM, which is kind of PAM stands for Pluggable Authentication Module, and this is just essentially an API or a framework suite to interact with the user accounts and the authentication of the set accounts. Now, the syntax for this is pretty typical, standard. It's going to be password, then the option, and then just the username. So like SeanZX, for example. So the various useful options that we have here are -L, and this is lowercase l as opposed to uppercase L for the user mod. So we're using lowercase l or -- lock rather. Oops, I think I did like, yeah, let's do this. So it'd be like that. And again, you need to be in root mode in order to do this. Otherwise, of course, you can't, and this of course will just make the password unusable, but you can still log in through other means. Then we have the -u command as we had previously, or the -- unlock command, and again, root only, self-explanatory, just unlocks the account. Then we have the -d -- delete command. And again, whenever I use this slash, it's just to indicate you can use either one. And again, this is a root only because this will delete the password, and implicitly when you delete the password, you're also kind of unlocking the account because there's no password required to authenticate into that user. So this is kind of a hacky way to get around a password lock in some cases, and it's useful sometimes when grubbing or chrooting. Then we have the -e command, which is, if you can guess, this is the -s expire command, usable in root only as well. And this just makes it so that when the user next logs in, they will be, after this expiration date, they will be forced to make a new strong password as defined by the password complexity in your etc password file, or password quality file in the security. Actually, I think it's etc security password quality. Let me actually just see. Just to make sure, security password quality.conf. Yeah, so as defined in that file and the login.defs file, that will be of course the new password that they will be forced to create. Then there is the very interesting, and I actually want to show this one, -s for capital S, or -status. Make sure to actually spell that right. And this will show you a bunch of useful information actually about your password. So this is useful with some, cron jobs and cron tabs and scripts that you might have, just to kind of do some auditing and logging of various information about your users. So this will kind of show you a little breakdown of the information related to that password. So it'll show you, of course, first the user. Then it'll show you this 2-letter kind of abbreviation, and there's a few different things that this means. So the first one is LK, which we actually have here, and that just means locked password. Then we have NP, which is no password, and then we have usable password, which is PS. Now, if you recall, I didn't actually set a password for this, but because we did some things throughout this video, it actually eventually kind of did something to the configuration that essentially treated this as having a password and having to be locked. So if we run again, remember that -u command, or if we do, let's do -g just to clear it out, and we'll do shanzix. So you can see that it deleted the password. It actually also warned us, which is nice, that unlocks the password. So if we do password -s shanzix, you'll see that it now says NP for no password and also shows empty password at the end there. So it also shows us the last date of modification to the password, including the time. So you can see that there, and some other information, and -1. I think that's for when the account's supposed to go inactive, and obviously -1 value would mean that would never go inactive. And so that is all the different values for that. And then if you remember, we have the group add and I went over the user add. So yeah, just group add. And then very quickly, I'll touch on deleting users. So you can use user delete, and then you just pass the name in. Now, it's important to note that this is really not enough. This is a very inelegant way of getting rid of their stuff. You would typically need to combine this with the -r flag in addition to their name, because if you don't, then it won't actually get rid of the home directory they have, the mail spool, and the skeleton directories assigned to that user. So there'll still be a lot of cleanup left to do. And typically, honestly, even doing that is not enough in some cases, as they might have some other files that are created by them and that they still own otherwhere in the system. So typically when you're deleting a user's account on an enterprise system and kind of cleaning up after them, you probably need some additional package or third-party tool to kind of scrub them fully out of the system. Ansible has some modules that do this and are very good for it, or you might need to just devise your own cron job with that runs off a shell script using like find and user delete. So that's just something to bear in mind as well. And that is pretty much it for this kind of small lecture video. I think at this point we are prepared to go into creating the shell script for creating those users and groups. I think now you have a pretty strong foundation on what manipulating users and groups is like, kind of the low-level technology behind permission bits, file modes, things like that. And of course, knowing where all those configuration files are helps a lot too. So yeah, we'll go ahead and move on to that task 11, and get further through the RHCSA lab. Thanks for watching. shanzix here. Like, comment, subscribe, all that jazz. See you in the next one. Peace.